You were ready to see the image they promised would be the definitive shot of 3IATLAS, that sideways photo taken at the exact moment the interstellar visitor skimmed past Mars. But what we got was a blur. A blur that conveniently appeared after weeks of waiting and after an entire lineup of observatories had been pointed at it: Hubble, Webb, HiRISE, MAVEN, Psyche, and dozens of amateur telescopes around the world. And along with the blur came another piece of news that should make anyone uneasy: 23,689 radio signals detected by the MeerKAT radio telescope. 23,689 pings in the range between 900 and 1,670 megahertz, a window that, in our jargon, overlaps with cell phone type devices. All this from a distance of 280 million miles from the object, according to observers. Don't panic. Operators said these signals weren't spatially aligned with Atlas and were therefore probably human interference. But then why list exactly 23,689 events if they were just noise? Why not simply say, "We detected nothing"? Here begins the storyline we're going to unravel between what shows up, what's omitted, and what the data may actually be pointing to. The essential problem: sharp image versus official image. HiRISE, the camera aboard the Mars Reconnaissance Orbiter, passed less than 20 million miles from Atlas and should have given us a sideways record with a resolution of about 19 miles per pixel, up to 3 times better than Hubble. It was our chance to see the object in detail and finally settle it: comet, rock, or something that doesn't fit into traditional categories. What was released, however, was a blurred image with light scattered due to spacecraft shake a record that looked more like a softened version of reality than a demonstration of what the technology can actually deliver. Meanwhile, amateur astronomers with modest telescopes posted stackings and time lapses that, for many, offered more visual clues than the official photo. Why does this matter? Because image quality defines what we can extract. Jet orientation, signs of fragmentation, plume, color, nucleus size, presence of structures around it. And when the official photo delivers less than the independent records, the inevitable question appears: what was filtered and why? The 23,689 signals what they said and what they didn't. Let's be direct. Detecting 23,689 signals in a technosignature search is not trivial. Even if reviewers later conclude none of them aligned with Atlas, the mere fact of recording them has implications. First, it leaves a documentary trail. If something consistent appears later, that material can be revisited. Second, the wording they used, likely human interference, doesn't close the door. It's careful. It's not a "we detected nothing." It's a "we detected something but couldn't link it to the object." That nuance is powerful. On top of that, alternating hydroxyl signatures appeared and vanished in short windows. Hydroxyl can indicate interaction with water, or it can arise from material expulsion mechanisms. Intermittent behavior raises hypotheses about cyclical, natural, or artificial processes that deserve deeper investigation. The anomalies why Avi Loeb is uneasy, and why you should be too. Astrophysicist Avi Loeb compiled a list of Atlas properties that, taken together, form a deeply uncomfortable picture for the ordinary comet category. Let's restate them clearly. 1. A trajectory aligned with the plane of the planets, statistically unlikely for a random interstellar visitor. 2. Collimated jets pointing both toward the star at the center of our solar system and away from it, creating long, narrow structures never before observed at this level in natural comets. 3. A combination of mass and velocity that is extremely improbable, millions of times more massive than Oumuamua and thousands of times more massive than the comparative comet, yet still significantly fast. 4. Fine-tuned passes by Mars, Venus, and Jupiter as if the object were following a schedule. 5. A composition with excess nickel proportions reminiscent of industrial alloys. 6. An extremely low water percentage, unusual for typical comets. 7. Extreme light polarization, exceeding anything ever recorded for an object of this category. 8. An apparent origin from the direction of the famous WOW signal, a statistically improbable coincidence. 9. Brightening and color change near perihelion, becoming brighter and more bluish than the star at the center of our solar system, interpreted by some as turning on an engine. 10. An inconsistent energy requirement, the jets would need a collector area far larger than the nucleus. 11. No fragmentation despite jets so powerful they should destroy any natural body. 12 jets remaining stable even as the object rotates, suggesting directed control, not chaotic emission. Each anomaly alone can be debated, but together they form a mosaic that doesn't fit the catalog of natural comets we know. When the physics doesn't add up the critical point. Let's simplify the issue without softening its seriousness. The jets recorded around Atlas stretch for millions of miles. That alone is an anomaly. For a traditional comet to produce jets that long, the sublimation rate would have to be colossal, and that rate demands energy. Energy provided by the light of the star at the center of our solar system. But when we calculate the energy required to sublimate carbon dioxide at the observed scale, we reach a massive requirement. Atlas would need to absorb energy equivalent to 3 × 10 raised to the 18th power joules during perihelion. To absorb that, it would need an area larger than 600 square miles. That corresponds to a body roughly 14 miles across, about 4 times larger than current estimates. If it were water instead of carbon dioxide, the required diameter jumps to more than 30 miles. The result? There isn't enough surface area on the object to justify the strength of the jets. Either the jets aren't from natural sublimation, or there's a hidden energy source. Collimated jets, stability across millions of miles, excess nickel and intermittent hydroxyl emission, extreme nature? Maybe. Technology? Also possible. Plausible hypotheses that must be investigated. 1. Directed thrusters. 2. Controlled ejection systems. 3. Mini probes accompanying the nucleus. 4. Industrial-like surface structures. 5. Artificial electromagnetic emissions. Dr. Avi Loeb argues it's not mind abduction nor fantasy. It's simple. When the natural doesn't explain something, you test the artificial. That's the scientific method. The official briefing, lots of words, few explanations. The agency's press conference seemed rehearsed to avoid the word anomaly. The vocabulary was carefully chosen to convey normalcy without addressing any of Loeb's 12 critical points. It's not conspiracy. It's scientific politics. Give the minimum information required to avoid explosive headlines without entering the uncertainties that actually matter. The problem? When institutions remain silent, the community fills the gaps, sometimes with theory, sometimes with imagination. Amateur astronomers gave the public something the major agencies didn't. Clear, stable, unfiltered images. Many of them show narrow jets, unusual colors, rapid brightness variations. Lateral structures the official image doesn't display. This created a curious phenomenon. The public began trusting backyard telescopes more than official photos. And that's not bad, it's healthy. Science is community, and critique is part of the process. The next few weeks are critical. We need more precise spectra, firmer mass loss measurements, renewed, targeted searches for radio signatures, multiband imaging capable of revealing many objects or structures around it. If any of these show up, we may reach a turning point, and if none do, we'll still learn something. Both paths teach us. Atlas arrived as a question, and it remains a question. Between the HiRISE blur, the 23,689 signals, the absurdly long jets, the unusual composition, and the selective silence of institutions, we have far more doubts than answers. And that's not bad. It's science in its purest form. If Atlas is natural, we'll discover new frontiers of interstellar chemistry. If it's technological, we'll discover that we're not alone. In both scenarios, we win. What matters now is refusing lazy explanations and continuing to ask the right questions. What do you think about the data? Do you believe the 23,689 signals were truly human interference? Was the HiRISE image really as bad as it looked? Did the jets make sense to you? Comment and share this video. The conversation needs to continue. And subscribe to follow along. The story of Atlas is far from over.